All right, we will pick up from the next page, but I particularly don't feel I need to do this. This is exactly the same as the previous page, what we had done. This is e to the power of x, and what we had done in the previous example, it was 10 to the power of x. So just my values will change. When I take x equals -1, this is basically going to be, this one is basically e to the power of -1, and this is basically e, right? So that's why it's 0.37, 2.7. So it's exactly the same thing as what we did the previous time. And what I did for my log was I switched my x and the y and plotted that. And I got something that looks very similar to this, except the growth is not as fast. Here my base is 2.7 ... whereas my base there was 10. So it obviously was growing much faster. But the shape and everything is the same. So it's exactly the same example, and if you had followed my previous example, this should not be a problem. We're going to look at some more graphing in our next few pages of how to graph, and it's just not the basic parent function if there are transformations. So the steps that we're going to follow is, and the reason I'm putting up the key is because, hopefully we've already filled up the key, and so I can just read it out and make sure that. So when you're given a graph, when you're given a function to graph, a logarithmic function, this is what you're going to do. You're first going to graph the points for the exponential parent function. Okay, so first, that's the first thing. You're going to graph the parent function of the exponential. Then you're going to switch the x and y, just like what we did, to get the log function. Once you get those points, you're going to stretch, you're going to plot the points, and then you're going to stretch and reflect it in the necessary third column and apply your horizontal and vertical shift. I actually like to apply my horizontal and vertical shift even before I plot, so that I kind of have the direction. I personally 3 and 4 can, but you can do it as you start graphing. You'll see what you're more comfortable doing, and things will fall into place. So let's go ahead and start graphing our logarithmic function, and we'll do a couple of these and we'll see how this looks like. So hopefully like I said, we filled in this with our key. So let's go ahead and take a look at how we're going to graph this. So this is what I need to graph. I need to graph log base of 2 x minus 1 plus 2. That's my function that I need to graph. So remember what our first step was. Our first step was to graph the parent exponential function. So my parent exponential, because my base is 2, my parent exponential function is going to be y equals base of 2, so 2 to the power of x. And that's what I'm going to graph first. So this is my exponential, so y equals 2 to the power of x, -1, 0, 1. So 2 to the power of -1 is half, 2 to the power of 0 is 1, and 2 to the power of 1 is 2. Now what do I do? Now I need to, now I'm going to go to the log. Log is, you write it as log, you take the base from here, and it is x. And then I'm going to switch the x and y. So this becomes half, this is 1, this is 2, and my x columns becomes -1, 0, and 1. So now what you need to do is, now you need to graph, but let's just quickly make sure that we write down what we're going to be doing before we jump into it. So you are going to lightly graph this. You're going to lightly graph this and apply. So what are we looking at here? So let's go ahead and make sure what do we need to apply? We need to apply 1 forward, because -1, remember this is 1 forward and 2 up. So you're going to take each point, and each point is going to move 1 forward or right and 2 up, whichever, however you may call it. So this is how you want to be doing this. Okay, so let's go ahead and start graphing it, and then we'll fill in the other points. So my graph is shown here. So I want to be graphing this. One more important thing. So remember, logarithmic graphs have, because log, they have vertical asymptote. Vertical lines are basically, so remember, vertical lines are lines that go vertically. That means it goes through some x point. So it's always x equals some value. So in this case, what's it going to be? So normally it's x equals to 0, but there is a shift. So it's x equals to 1. So this is important. So that's, I start off straight with that. And then I go ahead and, so we have to keep this in mind while you're plotting. But let's go and plot the original points first. So I'm going to plot when x equals to half. So I'm going to go ahead and write this down here too. Vertical asymptote of x equals to 1. Okay. Keeping this in mind, let's go ahead and lightly graph this. So when x equals to half, y equals to -1. But remember, lightly graph and then apply. So this is not the actual point. So this is my initial point and I need to move it and then apply my transformation. When x equals to 1, y equals to 0. This is my parent function. And then when x equals to 2, 1, 2, y equals to 1. Okay. Now take each point. This is lightly graph. Take each point and apply 1 forward and 2 up. So 1 forward is 1 forward and 2 up. So this is my first point. And then go to the next point. 1 forward and 2 up. Third point. 1 forward and 2 up. These are the points that are my for my final graph. And then let's go ahead and draw an asymptote. My asymptote is here. X equals to 1. Now it's easy to see how I can connect these points. And on the other end, go towards the asymptote, hugging the asymptote, but not touching it. There you go. You have your graph now. So let's go with the steps again. So you first have to, you were given a log graph with a base of 2. So you need to create a table with a base of 2, exponential graph. Switch the x and y, lightly graph the x and y of the log function, and then apply your vertical transformations, vertical and horizontal transformations. I'm sorry. Now let's go ahead and fill in these values. We're going to go ahead and fill in these values. So my vertical asymptote is, we already talked about this, x equals to 1. My y-intercept, I see that it's not touching my y-axis at all, so it's none. X-intercept, okay, so now I see that I am not able to find the x-intercept here. I'm not able to find the x-intercept. In the sense when I say I'm not able to find, it's not a whole number, it's a decimal. So how do I get this exact value? So remember, x-intercept basically means y equals to 0. So you're basically saying, so you're going to be solving this. So let me actually see if I can do this on a separate piece of paper. So I know y equals to 0. So 0 equals log base of 2 x minus 1 plus 2. Can I solve for this x here? And I know y equals to 0. So let's make this as a 0. So I move the 2 over to this side and I get -2. So log 2 of x minus 1 and negative. Okay. Can I solve this? Maybe. So this basically, how do I solve this? So I convert this into base 2, raise it to the power of -2 and x minus 1. So what's on this side? 2 to the power. So this is 1/4. Everybody good? Because, you know, you take it down, and then plus 1 equals x, which basically means x equals 1/4 or 5/4. That's how I'm solving for my x-intercept, because I know how to convert it into an exponential and then solve it. So it basically means my y equals to 0, x equals to 5/4. So x equals 5/4 and y equals to 0. Alright, so I hope this makes sense. I'm going to leave this on for a couple of minutes for anyone who needs to copy this as to how I got that x-intercept. It's an important concept, and it's, you know, it's something that we need to know. We always need to know how to solve for x and y and, you know, go between logs and exponents, but that's how you're going to do it. So yeah, okay. I'll pause for you to be able to write this, and you can put the pause button and write this, but otherwise remember, log functions don't have a horizontal asymptote, so that's going to be blank. And go ahead and fill in your domain and range. My domain starts at 1, but 1 is not included, and goes to infinity. My range is all real numbers, or -infinity to +infinity. Okay, now let's look at our limits. Limits, you have to pay a little attention. So as x is going towards, can I say -infinity? Not really, because there's no value beyond 1. So as x is going towards 1, but you're moving it from this side. There's nothing, so 1, but from the positive side, So as x is going towards 1 from the positive side, it's dropping. So that's basically negative infinity. And as x is going towards positive infinity, that's going to be positive infinity. There we go. We have got the graph and we filled everything in. Let me go ahead and do the next one. I'm going to keep doing till we have, hopefully you should follow all my examples. These, like I said, this is so new, and I'm hoping that you're able to follow the videos and learn. All right. I'm going to do one more graph and then we will stop and then we'll start another video for the next page. So this is basically log base of half, and then so this will have a, remember it's a log, so it has a vertical asymptote. Vertical lines are basically x equals to something, so it's going to be x equals to -3. I'll just go ahead and write that down for now, even before I start anything. But anyway, I should go ahead and start. What's the first step? The first step is to make sure I know my base. So my base is, if you look at the log function, it is half to the power of x, and this is what I need to create a table for. So y equals half to the power of x, -1, 0, 1, half to the power of -1 is 2, and this is half to the power of 0 is 1, half to the power of 1 is half. Switch the x and y, so this becomes log base is half of x, 2, 1 and half. I just copy this and then switch it. And now I'll go ahead and graph this. I will need to graph this. Okay, but before we graph it, let's go ahead and see what we are exactly doing. Because we are basically going to graph lightly, because that's not your final points, and then apply. What are the transformations taking place? Go back and look at your equation there. The only transformation taking place is x plus 3. That means you are moving 3 to the left and there's no up or down. That's the only thing that you will be doing when you're doing this. Okay, so let's go ahead and graph this and then apply this. So when x equals to 2, y equals to -1. So this is 1 point. When x equals to 1, y equals to 0. When x equals to half, y equals to 1. But remember, each of them moves 3 back. So this is 1, 2, 3. So this is 1 point. And then we're talking about 1, 2, 3. This is another point. And then 1, 2, 3. This is another point. And then before I join the points, I want to draw my vertical asymptote that I wrote as x equals to -3. 1, 2 and 3. So this is my vertical asymptote. Join these 3 points. On the other side it grows this way, but on this side it hugs the asymptote. That is my graph. And based on what I said, you can fill in what's on the top. It should not be too difficult, and you can follow with the key.